Hello everybody, it's Gordon Henderson here. Today we are doing some 8-bit basic comparisons. And I've got in front of me here, what you're looking at is the terminal screen on my Ruby 816 board, but for the most part we're going to be running it in 8-bit 6502 emulation mode. And the reason I'm doing this is because I've just recently ported the latest version of EhBASIC, which is a 8-bit basic, runs on a 65C02. So I'm using the 65C02 version, and I've ported it to my Ruby platform, and I'm going to compare it with a standard Microsoft Basic, which is CMB2 and bbcBasic. And I'm going to use exactly the same program in all three basics, and we'll see how we get on. So the results are quite interesting. I've done this test before, so I sort of knew what the results were. But I thought that the CMOS version, the 65C02 version of EhBASIC, might be a little bit faster than it was, but actually it's not really. It's not significantly faster for the little test that we're doing. But let's start off. We'll run up EhBASIC. So there we go. It's the version 2.22p5c, and the Ruby just says it's got my patches in it to make it work under the Ruby operating system. So there we go. It's sort of fixed with just under 32k of RAM minus what the operating system does. One of my patches was to change the line input so that I've got access to my usual star commands, so I can do the directory listings. And the exec command, which basically says take text from a file, and the file there, mandel.txt, is a text version of the basic program, and that's the program. And I'll publish all of this online. I've published this before. But we're going to use exactly the same program in each of the basics, which is the only way to make it fair. I'll just run it here. Now I don't have access to timing functions in EhBASIC nor the Commodore CBM Basic 2, so I timed this with a stopwatch. I'm not timing it at the moment. I run three versions, or three iterations of each one, took the average. The interesting thing is that the CBM Basic, when I ported it to the system, I quietly ignored Control-C checking. EhBASIC does have Control-C checking, but I turned it off to make it a bit comparison. At the moment it's turned on. In fact, I'll just demonstrate. I can Control-C it there. I turned it off because it actually adds 3 seconds to the runtime of the program. The results, actually, I'll give you the results here and put them below. But for EhBASIC, this actually takes 79 seconds to run. For Commodore Basic, it takes between 82 and 83 seconds to run. If I run up Commodore Basic, I did the same with the input. There's the program doing exactly the same thing. Yeah, so checking for Control-C added 3 seconds to the runtime of about 80 seconds. So EhBASIC was initially slower than Commodore Basic, but when I took the Control-C checking out to make it the same as Commodore Basic, it got slightly faster. So we're at 79 seconds for EhBASIC, 82.5 seconds for Commodore Basic. And this is what we're running now. We're running Commodore Basic. And I'll let this finish because I can't Control-C out, basically. I can quite easily add the Control-C checking in, but when I did the port of Commodore Basic, it was based on a version of MS Basic that Microsoft themselves had published the source code to, and somebody else had taken the Microsoft published one and sort of wrapped it around so that it would be easier to build and assemble for various platforms. So the source code is all out there. I'll leave links in the description below to the whole thing, so that if you want to try it yourself, you can get it and put it on your own 6502 system. Here it's coming to and end. Any second now. There we go. The 0 at the bottom is the timing code, which only works in bbcBasic. We'll run that at the end. And just to show you that this is Commodore Basic 2, there's the hidden Easter egg that was put in. So you wait 6502, 1, and it would print Microsoft exclamation mark to the top of the screen. I had to modify the Easter egg to just print it on the screen rather than poke it directly into screen memory. Because this used to run on Commodore PETs and C64s and so on. So last we'll run up bbcBasic. You can see at the bottom of the screen there. That's the version. Exactly the same program. The basics list them slightly differently, but internally they're the same program. And I shall run this on bbcBasic. Now, just one thing to note is that my Ruby board here is running at 16 megahertz. So if you want to run this on, type the program in and run it on your Commodore PET, C64, anything else that's running at a traditional old-fashioned 1 megahertz, you're going to be waiting a long time. In fact, the best part of 20 minutes. And even on a BBC Micro, this is much faster. You're still going to be waiting, sort of 12 minutes or so for this particular program to run. Things to note: the BBC version is much faster. bbcBasic. This is the Basic 4, which is the CMOS version, the 65CO2 version. 48.25 seconds. The floating point format in bbcBasic is a 5-byte format, whereas the floating point format in both EhBASIC and the CMB2 Basic is a 4-byte format. So even though we're using a bigger precision floating point on bbcBasic is still faster, still nearly twice as fast. But you could say it had the benefit of an extra 2 or 3 years of software development, given the BBC Micro came out at the end of 1981, and the Microsoft Basics for the Commodore PET, the Apple II, which is what EhBASIC is based on, a disassembly of Microsoft Basic, as far as I can tell. That was sort of mid to sort of 76 or so. So the boffins at Acorn had a good few years advantage. Some newer programming techniques to take advantage of, and it was also a bigger BASIC. I mean, the BASIC itself is 16K, whereas the EhBASIC and Commodore Basic are around about 10K. So there's much more in it. But there you go. That was just a very quick comparison of 8-bit basics on a 6502. I'll quickly, just as a wee teaser, if I run up my BCPL system, this is a 32-bit BCPL system running on the 65816 in native mode rather than 6502 emulation mode. So we've got a 32-bit virtual machine running on a 16-bit processor with an 8-bit memory bus. I translated the Mandelbrot program into BCPL literally line by line. I have not made any attempt to use any extra features. I'm using the floating point version of BCPL. This uses a 4-byte format. It's IEEE floating point format. And as you can see there is a couple of go-tos and a couple of labels. It is literally translated line for line, and I'll publish this up on the my website, and links in the description at the same time. So if I run this, somewhat surprisingly, it's a lot faster. And I say somewhat because the floating points is still doing. Every single character on that screen is doing floating point. The black areas, the colour depth, as it were, on this particular one is 18 iterations. So for each point on the display, at 26 seconds. So that's almost, in fact, it's slightly more than twice as fast again as the BBC Basic one. So every single one can do up to 19 iterations. The black space is where you get the full 18, 19 iterations. The dots is where you only get one iteration before it converges. If you want to play with the code, go ahead, play with the code. If you're using it as a benchmark, then use the same code. Don't alter it, because then you change the parameters of the benchmark and it doesn't become a good comparison tool there. But if you want to play with the code and do things, this is a version of another text version of Mandelbrot, again written in BCPL, but this uses scaled integers. So if you use scaled integers, you can go a lot faster, but your resolution is effectively less because you're at the resolution of a 32-bit integer here. So that's twice as fast again, and it's also got a color depth of 32. It goes all the way down to 32 here, which the other ones only go up to 18. So it's doing more calculations. They're all in an integer, which makes it a little bit faster. Anyway, there you go. I shall leave it at that, and I shall see you again. Any questions, comments, do feel free to get in touch. Thanks. Bye.